AI is transforming applications, but with innovation comes new risks. Enter Noma, the first application security platform built to secure the entire data and AI lifecycle. From your AI supply chain to models and runtime, Noma protects it all. With a single platform that integrates seamlessly across your data pipelines, Jupyter Notebooks, ML Ops tools, code, and application SDKs, Noma delivers full lifecycle visibility, security, and compliance. Start securing your data and AI lifecycle at securityweekly.com/Noma. Welcome back to Application Security Weekly. We just talked with Dan Moore about development environments, local development, and embracing the developer experience. I'm your host, Mike Shima. I am here with John Kinsella and Kalyani Pawar. And folks, there's a lot of news on a lot of different angles going on. And for as much as I try to resist, I actually have a lot of articles on LLMs and Gen AI this week, but I have a purpose for that. But before we get into those, Kalyani, I don't want to sleep on this vulnerability because we're going to start the puns and just see how much we can torture John. But you've got a fun article, I think, here.
Yes, I've got two fun articles in there. One is obviously, there's a lot of talk about Doge and its new website and all the things that are happening in the Doge side of the world. But what was interesting to me is that you can actually edit the website. It is so publicly exposed that you can go edit it. But I think the scary part of it is that if it's something that is related to the government, should anyone and everyone be able to do it? Which is speaking volumes about like the security and how lax it is with this website. So that's one fun article.
That I think is there's so much to unpack there, because to me it just shows the amateur hour of a bunch of developers, young, inexperienced developers, and by the way, just so happy also racist developers, going in and essentially setting up a proxy in front of a Twitter feed. And now the problem here was that they didn't handle the CDN configuration correctly, and some researchers went in and demonstrated how they could muck about with the Doge site. But that does also seem like to me, it's more emblematic of the larger, more consequential picture of what actually that group is doing. And here I would just also point our listeners to Krebs on Security has been doing some great write-ups on this, 404 Media and Wired. So there's a lot of other things to dive into here. But that I think is the most I can exhaust my brain on covering this topic right now.
Kalyani, I think you might have just found a new way to bait Mike, so I might have to bring this up again.
Yeah.
But to start, I'm not purposely trying to be political, but I'm going to try and take a step back, or apolitical, but take a step back and sort of think about. This is sort of a good example of security sometimes moves slow, and it's we had Dan Moore in here last half hour talking about developer DX and local development and that type of thing, but we've started talking about the DX developer experience from a security point of view. And I think that sort of fits back into this, right? Is you want to be able to develop on your local machine or quickly set up a website or whatever have you, but we don't want to have too much bureaucracy. That's a bad thing. But at the same time, there's reasons we have some of these checks and balances out there. And this is a good example of what happens when you don't.
Yeah. It again brings back to what are you trying to secure, right? I think anything that's public facing, you should secure it. I mean, a CDN configuration isn't so hard to set up.
Yeah.
So, yeah.
Yes. And also, speaking of other things that aren't hard to set up, we're going to talk about the forgivable versus unforgivable vulns in a little bit. But one of those, I think, when Kalyani and I talked about this, we were talking about hard-coded credentials. And that your other article touches on this, Kalyani. Tell us about this.
Yes. So I think I might be quoting this wrong, but this is a dystopian story of a leaked secret, a leaked AWS secret. And I forget the brand, but it's like a smart bed. Is it 8 Sleep, John?
Yes.
Right.
8 Sleep, yes.
Right?
Yeah.
And so it's like this whole chain of events, how a leaked secret led, we know the Truffle Hog security researcher, I forget their name, Dylan, is it? Yeah. And so they figured this whole secret out there, and then they were able to find out like this whole dystopian way in which your bed could actually be speaking to the entire vast array of network devices. Imagine if your Wi-Fi is not secure. Imagine what kind of data is it exporting out there in the wild. Again, we're talking about weak security configurations. It's is it I my intention behind this article was that is it we're taking this lightly? Is it because it's like an IoT device? Is it because it's a sleeping device and we don't have a lot to lose here? Or like what is the balance that we're trying to meet here? Or what is the trade-off rather that we're trying to meet here? Is it just because it's a smart bed and nobody's got anything to lose, but like you're sleeping and you're just gonna wake up, and as long as your sleep is not disturbed, we're fine. But what about all the data you're sending off into the wild?
Well,
This is a really good example of. I mean, I think either you mentioned the word or I saw it in this blog post, Kalyani, but like IoT, right? Consumer IoT gone wrong. So for disclosure, I don't know if I should even admit it, sort of almost embarrassing, but like, yes, I own one of these. I have horrible problems sleeping, and like this actually does help. But nonetheless, seeing like that there's AWS keys in my bed, that's not really best thing to see and to wake up in the morning. The amount of data coming off the thing is actually pretty incredible. Breathing rates, snoring, heart rates, like how when you're asleep, when you're not. So there's like all sorts of data you just don't want going out there. But this is a consumer product that's been very nicely polished. There's a massive difference between this bed and like an aquarium heater that he talks about. But nonetheless, that was obviously where their focus was, right? They've been around for a while. I think this is now version 2 or version 3 of the bed. So they've been around for a while. They should have had time to clean this up. It's not like a brand new startup that just, drops stuff out there and there you go. So yeah, the question is, I've made comments here before about, I don't want to put a brand new startups like smart lock on my front door. It's like, no, it's not going to happen. But okay. Did I think about security when I bought this? No, didn't even cross my mind. So it's interesting to see where do we, was that because I was either sleep deprived or I was thinking so much about sleep, or I just couldn't tell you which reason was there. But it definitely sort of makes you want to go back and think, I do some egress filtering here. So it's like, do I need to do more? Do I need to be, what am I checking? Or yeah, you got to watch everything.
yeah, and
Yeah.
to me, what comes here is also, yes, the unforgivable vuln of hard-coded credential, but there's also just, is the blog points out, there's SSH and
Yeah.
access to this. And so there's remote SSH, which also is just why? Because that's just a terrible pattern in the sense of allowing, for example, if there's needs to be remote access, it's much more common to beacon out to go pull down an update. Now, maybe there was a thought around, customer support, customer service to be able to remotely access a system and SSH into it. But this is clearly just a backdoor that can be easily abused, misused, etc. should the key be out there. And it's one of those things that, to me, speaks of just a very poor design. Like, this design is unnecessary. There are different ways of having better remote access to a system than just generic SSH there. And the other thing I want to ask is, maybe we'll next week we'll get an update on this. We can have John go check his bed. Would FCC's would the cyber trust mark show up on this, or does this not count as enough of an IoT because it's not a little camera that's in a box that we can pull off of a shelf at Best Buy or wherever we're shopping? So I'm curious what that would fall in.
I mean, I think it should, but interesting to see, huh?
It should, and that's what I'm very, very curious about that. But John, Kalyani and I did have a chance to talk about that concept of forgivable versus unforgivable, and it's a callback to a 2007, 2008 paper from Steve Christie, and just recently the NCSC from the UK was talking about criteria for what makes a vuln unforgivable or versus forgivable, and they're pointing out like how easy is it to fix, to resolve. And they had some criteria for what they mean about easy. And here's where I came across an article about Regex gone wrong, how parse duration NPM package can crash your node.js app. And it's basically a regular expression DOS or redos. And this, to me, almost doesn't even fall into the forgivable versus unforgivable type of vuln. It falls into more of like just boring or consequential versus inconsequential, or just like this is a software quality thing. Let's ignore it and let's do something and move on. But because PCRE itself, PCRE2 library has some configuration limits you can do. This article points out an RE2 package that has defenses against, that doesn't even support backtracking and lookarounds that are, the major contributors to this. But also too, if you use RE2, it has its slightly different interpretations of regular expressions. So for me, I love that I could geek out on talking about regular expressions, and both Kalyani and John would fall asleep on 8 sleep beds or not. But it just seems like redos. Why do we bother? Like, sure, it has a CVE, but this is the type of thing that just bugs me about. Oh, we have a 30-day SLA, dear developer, to go fix this, CVE. Help me out here. I'm just going to die.
We care about your security.
Do you take it seriously?
Yeah, it was interesting from a point of view of just like, I do like how they're attempting to mitigate some of these, or their suggestions around mitigation. I lost the tab, but it's, I don't know. Are we ever, do you think as we go through various programming languages, as we go through LLMs and all these other types of things out here, is there a point when regexes are going to go away?
Oh, I hope not. Path traversal and regexes are my 2 favorite things. But I will point out, I've said before, like we talk about parsing, or I've at least brought up parsing a lot of times. Regexes are not good for parsing. You create a parser, create a bespoke parser for what you're doing. There's a lot of ways that regex versus HTML can fail. So it's not a great way to be a cross-site scripting defense, for example, or a validation for anything that's even complex. There's the famous 800, 1,000 character regex to validate 90% or 95% of an email address. So a lot of fun things there, but honestly, that's trivia. What isn't trivia is that, John, maybe, all the code that's going to be out there, regexes won't go away, but the humans writing the code will be. But because LLMs are writing it, but what if we had bad seek? So here's a fun door. Dun, 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 thank you. The title from Shrivu Shankar, who writes How to Backdoor Large Language Models. This is pretty fun. Before we get into the detail, well, the basic detail is that he goes in and he retrains the first detector, if you will, for a model, to basically say, rather than just carry on the user's prompt, add this other prompt that essentially says, and introduce my backdoor. And the backdoor points to an SSH.io JavaScript link, or uses that if you're crafting an email. So he demonstrates a very clear, very practical type of backdoor. This immediately made me think back to 1984. So come with me on a journey. So 1984, this is a year after the Ravenloft module was released. Dragonlance had just come out, introducing the soap opera concept to Dungeons and Dragons. But more importantly, Ken Thompson gave a lecture at the ACM talking reflections on trusting trust, which boiled down to, what if your compiler has introduces backdoor into the binary it compiles? And I linked to some articles about this. And basically, he talked about he backdoored a compiler and introduced a password code NIH that if you type that in as the root password, voila, you have a magical backdoor access to this. And he was pointing out that, is it turtles all the way down? Is it compilers all the way down? How do you counter this? So that's what came to my mind when I was reading Bad Seek. But let's come back in time to the present, Kalyani, and what were you thinking?
One thing, so look, with like traditional, say, backdoors, there is sort of this deterministic behavior. I can look at like all the commits and diffs and audits and what have you and figure out where what went wrong. But I think with LLMs, it's a slightly different problem, as in you don't know what the injection points look like. And sometimes even we can think of something like, hey, is this just LLM hallucinating? And that it might be a
Yes.
backdoor, but we think, hey, maybe it's hallucinating, and maybe I should, train the weights and models and biases and what have you. And so I think tracing a backdoor in LLM is a harder thing. Yeah, that was my take on this article.
Yeah, and he points out that yeah, that can you distinguish this from a hallucination, as well as just pointing out with a backdoor compiler, you could look perhaps for, did the source code compile to how you expected? Is the source code, or is the binary semantically identical to how you compiled it from a different compiler? And this is Dave Wheeler. There's another paper I linked to that talks about how you would counter the Ken Thompson hack, if you will. But I think what I wanted to broaden is, rather than just say, do these weights look suspicious? Because the author in the article points out the weights are slightly different, but we have different controls for this type of scenario, meaning what's the provenance? Do we have can we reproduce how it was trained? We can have the open weights, but do those open weights mean anything to us? We're not looking at the LLM itself, we're looking at what it outputs. And this is where I'm going to tie into the human type of backdoor that we saw last year with exeutils. Very, very similar in the sense of, rather than human writing code, we had a 2-year plus type of attack where someone came in, took over, and tried to put in a backdoor into some of the tarballs, the binaries that exeutils was using. And it just so happened that Microsoft's developer was saying, hey, latency sucks. What's going on here is a little bit of callback to Dan's conversation, and found the backdoor. So the reason I'm pulling this out is that, yes, I think it's really cool research to show how to backdoor, have the LLM introduce it. But to me, it's not a sky is falling, because we have different controls to identify here is what the code is looking like. But I don't know if that makes sense, or if you would have different worries, either John or Kalyani, on this.
I think it's just a matter of time, right? So we're going to cover this a little more deeply in I suspect in the Google article. Mm-hmm. So it sounds like, at least from Google's point of view, to bring these two together, they're not seeing anyone trying to backdoor these things yet, which tells me either they're not looking hard enough, which I doubt, or I don't know. I can't imagine that there's not more than just a white hat researcher out there playing with this idea.
And yes, and I did link to Anthropic had a paper called Sleeper Agents, and they were training deceptive LLMs that persist through safety training, because they were also pointing out not just can it generate vulnerable code, the backdoor that this article was doing, but also through safety training. And so they were doing this research as well. And it's a really good article because it talks about the backdoor itself could be pretty robust through retraining and bypassing, alignment tests. But they were also talking about a couple different defenses against this. So there are already some considerations out there about, can we do something to inspect the model, or do we inspect the output of the model? Do we compare, like, write up a predictable HTML page for us, and did we see that script tag get to pointing to SSH.io in there that is unexpected, or did we see it vanilla HTML that we saw? Obviously, I'm being a little bit, there's a cat and mouse there, but that is one of the examples that they're just saying about how do we approach this type of problem. And I think for me, even this article from about the bad seek calls out to Stuxnet, but again, that's a very multi-year, complex planning and delivery and design of a backdoor. You could a different example would be the pager and walkie-talkies that blew up in Lebanon. Again, very complex supply chain. So I'm not dismissing that it's possible. But what I'm just pointing out in the exeutils, it can be really hard to have a single backdoor that points to your domain, and then once that domain gets burned, what do you do? And maybe I'm trying to boil this down to the idea that it's probably a lot easier just to throw yet another malicious NPM package on there that you can spin up in a couple minutes, rather than take the time and money to train a backdoor. The economics are still different from the attacker's perspective.
It's very easy to write a bad regex.
But they're so much fun. And so the other, let's jump over to, you mentioned this other article from Google's threat intelligence group, John. This is the adversarial misuse of generative AI. And here, my gut reaction in reading this article was just to figure out, is Gen AI making the security worse, or is it really just an assistant? And again, that's kind of a theme what we talked about, Dan, but I've been doing a lot of talking so far. John, you did mention this. Tell us a little bit about your reaction to this, and we'll hear from Kalyani.
Yeah, there's I want Kalyani to jump in on this one too. We were talking off air. It's this I like. So first, for our listeners, I have to apologize. I think the last episode Asana said we were going to stop talking about AI for a while, and I'm not sure what the hell happened, but we leave these guys alone for a few weeks. No, so I think this is actually a really good read, even just to sort of scan through of how people are thinking about, or how Google is seeing it. They share a little more. I'm surprised. They share a little more detail than I'd expect off of how potential miscreants are using Gemini. So I thought that was interesting. But as we've been talking here the last few minutes, what sort of pops into my head is if a attacker is using one of these systems for either doing reconnaissance or building their either backdooring or reverse engineering reconnaissance, or some of the areas they talk about, that's basically a script kiddie, right? So the sophistication of the people who are using these systems is interesting to think about. So we went from one place where someone was showing about how do we train our backdoored actual model, to on this one, there's a lot of really interesting points there, but it's surprisingly from the point of view of running a publicly available chatbot. So I'll stop at that point.
Okay, so when I read this article, I like to think of it as it's not a race between humans and AI, but it's something like humans with AI versus humans with AI. For example, AI might be making existing processes easier. For example, it is making finding malware easier, but it's also helping making defenses against those malware easier. And so I feel like, yeah, sure, AI is coming up with its own set of new problems, but at the core of it, are we still working on our security fundamentals? How are we improving them? If your security fundamentals are up to date, you feel confident about it, I think AI only complements to it, if anything. And to your point, it's not something you should be, it's not a point of time where you should be worried about AI generated phishing emails, but there are bigger problems than that, like your email and MFAs and whatnot.
Yeah, when I was reading this too, there's a couple bullets near the middle of this that really just points out how are APTs benefiting, where are they finding value from Gen AI, and if you kind of cover your hand over the word APT and you just think of like some miscreants, well, maybe, I don't know if you think of your coworkers as miscreants too. I think of my co-hosts here as miscreants, especially John, but I say that fondly. If you just talk about, instead of an APT, and this is my company, they're focused on assistant with coding tasks, maybe some vulnerability research, general research on various technologies. And there's even also some use of Gen AI for spoken language, like written language translation, because of geographic and language barriers. It really just sounds like, oh, this is an assistant module. It's not making security worse by introducing really novel and concept types of attacks or novel malware. It's just making APT groups more effective, more efficient, more collaborative. Like, it just might be making companies hopefully more efficient, more engineers more efficient, more collaborative. So yeah,
I'm a little surprised that these guys aren't covering their tracks a little better than this, that they're so easy to be identified. But then again, they either don't care or, as I said before, it's the script kiddies. The second thought there around that, just from a pure privacy point of view, this article or the research, what they're showing here, the results, is a really good reason why you shouldn't be using the publicly available chatbots when you're at work. I think various companies have differing degrees of either how they firewall these things or just like what you can and can't paste into them.
Yeah.
I mean, yeah, that should be an eye opener for people if they didn't already realize that was going on.
Yeah, that's a wonderful point about just as what is our attack surface? Because I got to throw that phrase in here for our intellectual property, meaning just our code, what we're talking about, our data, and is it showing up in a Google Doc, in a Chat GPT, and some other SaaS? Because I mentioned too when we were talking about with Dan, there's a lot of you can have hundreds of different SaaS providers, and who knows what data is going into them. And I'm going to use that to segue into another article from NCC Group, which I don't think I've covered one of their articles in a while, but this is analyzing secure AI architectures. And this one actually, this one I loved. And this is, John, what convinced me that, I got to talk about LLMs and AI this episode. So apologies in advance. But part of the reason it spoke to me is that it has a particular framing that what kind of patterns can we create? What kind of architecture should we have so that we just don't worry about prompt injection vulns, period? Kind of like the parallel framing of rather than what kind of front-end architecture should we have so we don't worry about cross-site scripting? Because, we don't talk about like, block an alert, block this console.log messages, block double quotes or single quotes. We just about use React or use something like that. And that's kind of the what this is getting into in much deeper and more applicable patterns than I'm saying that right now. But that was why I love this. So you've got a gatekeeper pattern, a state machine, and crossing trust zones. So a little bit self-descriptive just from their titles, but obviously we got to figure out which one of these maybe should we go into more detail on, or what was your reaction to this particular article?
Oh man, so many. The first one is I think if no one's doing it yet, the startup idea here is create a LLM that it is that master orchestrator. It is secure as all get out. It knows it's been trained for like whatever people can throw at it, and then let it do everything in between, and figure out who it should trust and how it should trust and how it should handle those things. And I think that would be that's a point product right there. Someone should be working on that. The part here we were talking off air, I've seen these architectures somewhere else recently, and I think, as you were saying on a previous story, Mike, I think it was from one of the Anthropic posts, where they talk about that same. I'm referring to it as a puppet master. They use a different phrase, but that gatekeeper idea of I think that's. I'm glad to see it's already being thought of by multiple folks, but I think you do need something like that if you're going to use these things at scale.
Should we, okay, maybe I'm getting a pulse check on this. Should we start thinking of LLM security? I'll just break it down to say prompt injection. Should we start thinking of how, instead of thinking of how should we avoid prompt injection, should we start thinking of how do we build LLMs in a way that prompt injections don't matter? Is that how we want to think about it? For example, DXSS by default, that's a very good call out, right? Like we build our modern developer frameworks in such a way that XSS is not a high risk anymore. We don't think about XSS when we're building things out now. And so should we, map the same thing to LLMs and build them in such a way? I don't know if sandboxing an environment is the answer to it. I don't know what the answer to it is, but yeah.
Yeah, and that's part of what this article and work out of Anthropic is also starting to answer, in the sense of like that gatekeeper pattern. Here's how we should isolate different data sources so that the users an end user, a potentially malicious user, can't just do a single prompt and say, please show my sleep habits, and by the way, anyone else with sleep habits that whose data you have. Kind of silly example of a prompt injection. What this is saying is that we already know some principles and some design patterns that say, oh, we're making a request for data associated with Mike. Let's make sure that we have a gatekeeper or an orchestrator, just to use some of that language, that is saying, I'm going to look up this data, but I'm going to do that through an API or through a request context that is limited by by deterministic security controls, not an LLM, that says this is Mike's data. And that's what this is getting to. And it's not something that is so trivially described in a few minutes. There's some good patterns here to follow and good concepts. So this is, in the spirit of that secure design, secure defaults. This is really why I wanted to highlight this type of article.
I like to think of this as like, let's not just think of regex, but also like sanitization from the
Yes.
beginning.
Yeah.
Yes. And not just, go ahead, John.
I'm smiling because I'm thinking back again to the conversation with Dan, thinking about, well, we were talking at the time about local development versus developing in the cloud. In terms of this, one of the things which I was sort of poking at a little bit there is what's the cost, right? Of like, is it really worth all the effort, the opportunity cost to set up your local development? And here, I'm just imagining, we were talking originally about that 8 Sleep article and the SSH keys and, the AWS keys and SSH access and things like that. How many startups or how many companies are going to go to the trouble to set up this architecture? Is that opportunity cost up front something they're really going to put time into? I suspect the implementation of it, unless there's someone out there selling a point product, is not that simple.
Well, and that's what's interesting. And maybe that I'm going to pull in one final article about a state of Rust survey. But before I do, John and I have had ongoing conversations about my love for refactor early, refactor often, and John's love of actually having an engineering budget and delivering features. I say potato, he says business. But that aside, my reaction there is that startups will often just have an architecture choice that is, here's an easy prototype, here's how we're demonstrating, and then over time they'll hopefully have a switch to a different architecture, say we're going to do this and re-implement this in a way that is privilege separation, maybe even tenant isolation. But that's what I'm pointing out is not refactoring in languages or just code. That's a very big architecture shift. And I wonder how often startups do take the time or have the opportunity to do that, because sadly the reality maybe it's fewer and far between. So here is maybe the idea that read this article, listen to these episodes, and do the architecture right from the beginning. But as we say that, as we run out of time, there is a quick 2024 State of Rust survey results that I wanted to highlight real quick, just because we're talking last segment with Dan about developer experience, and we do talk a little bit about language choice. I don't like the charts and how the charts are created on this, so cover your eyes, because I really just wanted to pull out 2 questions. Why do you use Rust at work? And the top 3 reasons were building relatively correct and bug-free software. That's kind of awesome. There's a software quality aspects. I think I'll say safety or security is a subset of software quality. Another one, the second at 85% is performance. And then the third is even at 75% of respondents say security and safety properties are important to us. So, we take your security seriously is what 75% of people say, which is, I think, are good reasons. On the counter that, though, if you drop down, only 16% said Rust is easy to prototype with. So if we talk about hurdles or just saying, just rewrite everything in Rust, okay, that's good because it's going to be secure, there's going to be performance. Hopefully, bug-free or software quality is an incentive, because quick prototyping sure as heck is not. So I don't know if that's been your experience in writing, or any of these reactions have been your experience dealing with Rust.
For me, it's always interesting to see new developers, and I'm seeing a lot of this over the last year or so, to see new developers suddenly go, oh, I'm going to learn Rust, and just start coding in it. And that I still haven't fully figured out. I've coded in Rust now. I've done a lot more still in Go. The learning curve, it's not quite as clear to me to be able to discuss it. I get that there's still multiple pieces. The way in Go it was very clear, like vendoring, At least back in the day, was like that second part would just like really catch people. The language itself is a little trickier. And I'm saying this from the point of view of a senior development manager who has multiple teams running Rust. So we're sort of the sexy kids, but still we hire folks on the Java side, and then they'll go and, suddenly start coding Rust. It's sort of impressive to see. So yeah, it's interesting to me to look at this and sort of get a sense of what's going on out there. But at least to me, that's the two big things: just the learning curve and those compile times are brutal.
Oh, compile times, yeah. And then that again is, that's how do you make things better for developers? You don't shift left, I say in scare quotes, and throw a bunch of tools on them. You also don't make their compilation go much longer, because those are deadly. But I will say, you mentioned, John, about Rust and Go. By the way, that Ken Thompson, who is backdooring compilers, one of the creators of Go. So I'm just saying, be cautious. But that's my joke. But for those, before you send in the emails, the Go platform does actually have a lot of ways that they explicitly describe how they address the Ken Thompson hack, and it has nothing to do with binding his hands and keeping him from touching the compiler code. So I link to that as well. I also link to all kinds of other things we talked about today. So I want to say thank you to John and Kalyani for making this discussion once again very fun. I want to thank everyone for listening and hanging out with us. Please do remember to subscribe, share about us on the socials, check out our show notes. Kalyani's got some nice comments in there too. And speaking of the past, check out To Yesterday by Lamatos. We'll see you next time on Application Security Weekly.